Hg is the atomic symbol for mercury. That's why it says Hg. If I'm over here, can you guys still hear me okay? All right. Kind of a weird question, kind of a tough question. What I would advise is we're going to have density and mass and volume of two different substances going on at the same time. Now, I'm going to make a little chart. I'm going to make a gold chart and a mercury chart. For gold, the density is 19.3 grams per cubic centimeter. The volume is unknown. It's what the question is actually asking for. What volume of gold? I like to, the thing that I'm trying to solve the problem for, put a little question mark there. And if we have density and volume, it stands to reason that we'll have mass. The question didn't give us a mass of gold, though. Okay. For mercury, it said that the density is 13.6 grams per cubic centimeter. The volume of mercury is 100.0 milliliters. Since everything else is in cubic centimeters, I'm going to convert that. So times, it's 1 cubic centimeter for every 1 milliliter. So it's more convenient to have that as 100.0 cubic centimeters. And mass, I don't think it tells me the mass. But back in the question, it asks what volume of gold would occupy the same mass as 100 milliliters of mercury. If I can calculate the mass of the mercury, that would be, those two numbers would be the same. I have next to no information on the gold side. I'm going to look at the mercury side of this problem and, oh, no, that's not what I wanted to do. I'm going to look at the mercury side of this problem. If I have density, and I have volume, I could calculate mass. There are two ways that we could go about solving this. One is algebra. If I know that density equals mass divided by volume, then if I do a little bit of algebra, that over 1, cross multiply, I get mass equals density times volume. The other way to approach that is unit canceling or dimensional analysis. Mass is measured in grams. In order to get grams, I would have to multiply. So I have two units. I have grams per cubic centimeter, and I have centimeters cubed. Do you see how if I multiply those two together, grams per cubic centimeter times centimeters cubed would divide away and leave me with just grams. But you end up, either way, you're going to multiply density times volume. But determining how to do that, you could use the units or you could use the algebra. Either way, you end up with the 13.6 grams per cubic centimeter being multiplied by the 100.0 cubic centimeters. The units divide out. 13.6 times 100.0. I'm going to get 3 significant figures. and I could determine that the mass of this sample of mercury should be 1,360 grams. Questions about what I just did there, or is everybody comfortable with that? All right, now that I know the mass of the mercury, and it's going to be the same as the gold, because the question asks when the masses are the same, 1,360 grams of gold would occupy what volume? Again, I could solve this either with algebra. I know the density and the mass, and I want to solve for the volume. I could solve it with algebra, or I could solve it with the unit cancel method. With the algebra, so density equals mass times volume, rearrange it, I get mass equals density times volume. If I want volume isolated, I divide by density on both sides, and that gives me mass divided by density equals the volume. Unit cancel method, if I'm looking for volume, that's cubic centimeters. How can I take density, which is measured in grams per cubic centimeter, and do math with it? Mass is in just grams. How do I get to just cubic centimeters, which is the measure of volume? If I take grams times and I flip the density and multiply it by centimeters cubed over grams, grams will divide away and leave me with centimeters cubed. And that would be the 1,360 grams times 1 centimeter cubed for every 19.6 grams. And I didn't get that. If I come back over here, the math ends up being the same. Mass was 1,360, density was 19.6, volume should come out to be 1,360 divided by 19 point, or 19 point. Have I been writing that down wrong the whole time? It's 19.3. 19.3. 1,360 divided by 19.3. Calculator tells me that it is 70.4663. And 3 significant figures, 3 significant figures, 3 significant figures all around. I'm going to chop that and round up. So my answer is 70.5 cubic centimeters.